Hi everyone! In the last video I told you that there were some cases where we have to tweak the law of signs just a little bit to make it work. So that's what we're going to be talking about in this video. It's called the ambiguous case of law of signs. And basically what happens is if we're given the information where we have one side and another side and the angle between them, well, sometimes we can't solve for the third side. Sometimes there's no way that could make up a triangle. Or sometimes there are two ways we could figure out the third side. So there are two possible triangles that solve it. So what this ambiguous case, what these rules tell us is when we have no solutions, when we have one solution, when we have two solutions. And we're going to play around with this a lot in class to see why this is true. But for now, just treat it as rules. So here's an example of a case where we have two solutions. So let's say the information that I have is the side opposite A is 12. The side opposite angle B is 31. So the side opposite A is 12, the side opposite angle B is 31, and angle A is 20.5 degrees. So I end up with two solutions. One is where this third side, C, is pretty long, and my other angle, my angle B, is acute. I also end up with a solution where my angle B is obtuse, and this third side is pretty short. So you can visualize both of these together. So both this is 12 and that's 12. So this is the obtuse choice for B, and this is the acute choice for B. So let's just look at these rules. If our angle A, we're assuming that we have this information, little a, little b, and big A. So we're in the SSA case. If our angle is acute, then we have four different possibilities. If it's acute and the side length A that we're given is shorter than the height of our triangle, then we have no possible solutions. Because what happens in that case is we can't get this length A to touch down because it's shorter than the height of the triangle. It will never touch this base side. If A equals H, then this little a side is the same as the height, so we're left with exactly one solution where we have a right triangle. If A is bigger than or equal to H, then we have just one solution. This angle C is forced to be obtuse, because if A is bigger than or equal to H, we have to be on the right-hand side of H. But if A is between the height and the length B, then we have two possible solutions. We have a solution where B is obtuse and a solution where B is acute. And finally, if A is, well, I guess we have two more cases. When our capital A is obtuse, so we've got this big angle bigger than 90, if A is too short, if it's less than B, it can't touch down to complete the triangle, so we get no solutions. But if it's bigger than B, then it does touch down. We get one solution. So let's see how these rules come into play in a few examples. So here's our first example. The information that we're given is little a equals 22. Little b equals 12, and capital A equals 42. So if I begin to draw this triangle, I first draw angle A is 42 degrees, and I know this length is 12. And I'm going to have to figure out how long C has to be in order to have A be 22. So H here is equal to B times sine of 42 degrees. So in this case, we get 12 times sine 42. The reason I'm figuring out H is just so I can check which case I'm in, so I know how many solutions I have. So I should have 12 sine 42 is 8 approximately. So in this case, the height is smaller than A. So I definitely don't have no solutions. It's not equal to A, so I don't have the right angle solution. A is bigger than B, so I'm in this category, which is where I should have only one solution. So we can use the law of sines to, let's first find angle B. So to find B, I'm going to do sine A over A equals sine B over B. Sine of A will be sine of 42 degrees. Little a is 22. Sine of B is what I'm looking for, and little b is 12. So this tells me sine of B equals 12 times sine 42 degrees over 22. And I'll plug that into my calculator. So I do 12 times sine of 42 divided by 22. That's supposed to be sine of B. And if I take sine inverse of that, that will tell me what B is. So I get that B is approximately 21.4 degrees. From this, I can also figure out that angle C is going to be 180 minus 21.4 minus 42. So that gives me 180 minus 21.4 minus 42 is 116.6 degrees. And so now if I wanted to find side C, this little c, I would do sine of C over C equals sine of A over A. And that tells me that I'm going to do sine of 116.6 over little c equals sine 42 over 22. If you do this cross multiplication, we see that c equals 22 over sine 42 times sine 116.6, and that's approximately 29.40. So now I want to show you what goes wrong if we tried to find a second solution for B. So we know we're only supposed to have one solution in this case because little a is bigger than little b. But if we were to find a second solution, here's the idea. Sine is positive 0.365. Sine is positive in quadrant 1 and in quadrant 2. So this is our solution for B in quadrant 1. To get the solution in quadrant 2, I would do 180 minus this value that I just got. Because if this is 21.4 degrees, then the other angle with the same sign is going to be 180 minus 21.4. So my other possible solution, let's call it B2, will be 180 minus 21.4, which is 158.6. So that still seems possible, but then if I try to find C, that's going to be 180 minus 158.6 minus 42. That's going to give me a problem. 180 minus 158.6 minus 42. That's a negative value for C. So this can't happen because our second possibility for B2 was just way too big. So later we'll see a case where it actually does work. We solve for the second possible solution for B and it makes a triangle. That's going to be in this case where we have two possible solutions, where the size of A is between H and B. So here's another case. Here I have A equals 15, B equals 25, and capital A equals 85. So in this case, H again is going to be B times sine of A. And I'm checking this so that I can compare with my rules. So that's going to be 25 times sine 85. And so H is 24.9. So notice that little a is less than H, so we should have no solutions. So let's just see why that's true. So I'll try to find B by doing sine A over A equals sine B over B. Sine A is going to be sine of 85. A is 15. Sine B is what I'm looking for, and B is 25. So sine B equals 25 times sine 85 degrees over 15. 25 times sine 85, oops, that's supposed to be times, divided by 15, and I get 1.66. Now that means there's no solution for B because sine has to be less than 1. If I try to take sine inverse of that, I'm going to get an error. So no solution. So finally, let's look at this two-solution case. So how do I know this is going to have two solutions? Well, I find H is 31 times sine 20.5. 31 times sine 20.5. That is equal to 10.85. So I have that H is less than A is less than B. So I should have two solutions from the rules that we wrote above. So now let's try to find them. So first I'll do sine A over A equals sine B over B. And so I get sine 20.5 over 12 equals sine B over 31. So 31 times sine 20.5 over 12 equals sine B, and then I'll take inverse sine in order to get B. So 31 sine 20.5 divided by 12 is 0.9047. So this is a positive value for sine. So I could have a solution in quadrant 1 or quadrant 2. The calculator is going to give me the quadrant 1 solution. It says that B could be 64.78. Let's call that one B1. So this is the quadrant 1 solution. The quadrant 2 solution, I'll call B2, I get by doing 180 minus that. So that's 115.213 degrees. So now if I try to find C, I'm going to end up with two possibilities. Let's do C1 first. We get that by doing 180 minus A minus B1. So that's 180 minus 20.5 minus 64.78. And that tells me that C could be 94.72 degrees. But if I use the other possibility for angle B, then I'll do 180 minus 20.5 minus 115.213. And I get 44.287. So this tells me I have two possible triangles. One is this one, where A is 20.5, B is 64.7, and C is 94.7. So this is B1 and C1. And here I still have little a is 12 and little b is 31. And I have this other triangle with B2 and C2, which has B still equaling 31, A still equaling 20.5, but then C2 is 44, and B2 is 115, but I still have this as length 12. So that's like I put it here, and this one was C2, and this one was B2. So I hope that these examples clarified some things. I may make another video with just more examples for those of you who want to see some more examples, but we'll play around with these in class and you'll get a good sense for why there might be two solutions. So keep practicing and I'll see you soon.